I would like to talk about a new tool what we introduced earlier in this year, which is called Structure Checker. And in the new version of 5.4, this earlier was the first one, we'll have more integration and improved capabilities. Actually, the problem what we faced with was that there are many molecules as soon as you receive SD files from the clients and the customers, which are crap. Some of them have very strange bond layout or something we don't know what is this, and surely some errors. A valence error is a quite simple case, but there are many others. And we found out that we developed a structure checker framework, which structure checker framework contains small tools that can detect a certain type of issue and then highlight these issues in the molecules, and then either manually or automatically these problems can be corrected in most of the cases. In 5.3, we integrated this new structure checker API in Marvin Sketch. Ákos will talk about it tomorrow and show you live how the Marvin Sketch integration works in the scope of his Marvin presentation. It's like a chemical spell checker in the application. Let me tell you something about the framework. So checkers are small classes. Each of them are responsible for one type of error or issue. And also have some fixers, like cleaning fixer or ungrouping fixers. And these do not know anything about each other. So one checker might have a fixer or might have more than one fixers available, or maybe there are cases which just detect an issue, but without the chemist, it is not possible to fix it correctly. This is about the class hierarchy. It's a simplified view. We have a structure checker interface and atom checkers, bond checkers, and other like aromaticity checker are inherited from it. And then from these ones, some specific checkers like valence error checker, bond angle checker, and so on. This is an extensible framework. So you can add your own checkers. We plan to add the document checker, which will allow you to validate not just structural data, but structural data with some text and numerical data together. So it's an open framework. You can add your own business logic to it if you want to use it. We distinguish two types of checkers. This is the current list of checkers what we implemented. Some are called error checkers. In this case, we are sure that the molecule has an error. In the other case, these are features, properties, these issues which are present. Might be good, might be a potential source of a problem, like an alias is on it. You often can't realize that there is a label as NH2, but in the formula there is no nitrogen. And it turns out that NH2 is an alias on the top of a carbon. So it can be misleading. So, but certainly the registrar and the user can specify what kind of checkers should run, because it depends on the applicability. For example, when you draw a query structure in a database, you do not want to warn the user that he had a query atom or a query bond. But if you have a molecule table in which the user inserts a new molecule and it contains query features, it should be warned that there is a query feature in your molecule. Do not insert it. And now I would show you a new wizard-like application. It's quite similar to the ones we already have for reactor and standardizer, which works with files. And see a batch checking of some procedure of some files. I recorded a video. It works just yesterday. I couldn't connect my computer to the same projector. I don't know why it works now. It's okay. So this is the wizard. As in all cases, we load one or more input files. So these contain few errors, but actually I recently ran on 500,000 database of a structure set, and these are just selected issues. On the left, here are the available checkers, and you can manually add the required ones to the queue on the right. You can open and save an entire configuration. I just opened one containing most of the checkers. Some checkers have options, and you can also find whether you want to fix it manually or you want a specific fixer to run, or just do not fix this type of error. So for each checker, you can individually configure the behavior. But usually there are not many options because they are very simple elements of actions. How we filtered the left list and added the solvent checker to the list. It will warn you if it finds solvent next to another component. And here, I just pause here, I think, if I can. Here we have some running modes. Actually, I start from the bottom. Fix just start the checkers as they were configured. So we configured them in the first page, in the previous page, that run automatic checking or manual checking or do not check this kind of issue. So fix is the one which runs according to that. The other three overrides those settings because I have a setting, but for example, I want to just get a report. So just check doesn't change the molecules, just provides you a report what was wrong. In a manual mode, all of the issues are displayed for you. For example, with smaller sets, I prefer to see what kind of errors I detected and do not want an automatic procedure. The automatic method will show you nothing. It will just generate the molecules and fix them if it can. If it can fix, if it cannot fix, then the original molecule will go to the output. And now, I think we will run a manual check and see each of the problems in this 18 molecule file. I specified an output. We have a single output file here. So for each input molecule, there will be an output molecule, except if you click the discard button here in manual mode. So this is the first one. It turns out that this is not a ring. These are overlapping atoms. So the fix here for overlapping atom checker is just clean. Here is another similar case, some bond angle errors as well. We save it too. Now we accepted it. Yes, another kind of formatting issue, we accept it. Here we have some others, not just bond angles and bond lengths, but here is another issue. The charge was added automatically, though this is a bit, and I added manually another charge which was missing because it's probably an isocyano group, and we accepted a 5 with an error because there was a kind of crowded bond there, but we can accept it if you like it. So this is when you can manually interact with the tool and do the registration in a controlled way. For example, I like this layout even there are extremely long bonds, but here is an abbreviated group. I can fix it selectively, so all other problems are left. here we have an upside down wedge, while on the other side there is an opposite one. I just don't know what is this. Fixing will expand it. Okay. Here we have another abbreviated group. So even in the manual mode, you can use the fixers, or you can draw. Here we have NO2s and abbreviated groups, and some bond angle problems. This is a trans bond in a small ring. So we warn in this case. I manually correct here. It's okay for me, so I accept. Very typical issue. One kind of ferrocene form from a database. There are many. We have a metalocene checker which recognizes all of those we are aware of and convert it to a coordinative format. There were some radical issues as well, so many things corrected here. What is this? Probably it's a pseudo-atom or an alias on the top of a single air atom. So I just discard it. It won't go to the output file. And these nitros, what I thought that these could be nitros, but they are strange. It's just this is the case when I'm probably not a chemist. A chemist was given the task that draw these kind of structures into your database, and this is the result. All right, wedge errors here and some others. I think this is probably the last. Checking. Actually, what you see here is the fully manual process. This is not necessary to follow. So if you know your molecules and know how the structure checker works, you can develop a system which creates an automatic registration. It's automatic validation, an automatic validation of the molecules. For example, in the automatic mode here, we can generate a report. One report is when you generate a log file in a text file. Another way is when we generate it into the molecules in an SD5 field. And now we have separated output, one for the good molecules, one for the bad ones. So you can separate them. It is not necessary to specify both. If you just need the good molecules, we generate a separated output and specify that file name. And now in the report, we get a report for each molecule, what kind of problems were found, were they fixed or not, and this report is inside for each molecule in an SD5 field because we selected that report. So if you open a molecule, the field contains an information that what kind of error was detected in this molecule. So this is this structure checker wizard which works with files. However, we have lots of applications which could use this kind of validation. Database tools, for example, like Instant JChem, Cartridge JChem base, we have web services and others. The integration in these tools is a kind of, there are two different models. One model is that we just want to report the existing problems. If you have a database, and we have chemical terms language where we can have functions, and it works in all of these tools, why don't we just have a kind of exclamation mark by the records where there is a problem. So we added 3 new chemical terms functions. Isvalid, which will give you true or false if a molecule has any problem. In this parentheses, you can have a specification of the error of the checkers like query-atom, bond angle, or aromaticity check, and sometimes options like basic aromaticity check. For each of these functions, this kind of action string is the same. The check method will give you passed or failed, as a string, and also if the molecule is invalid, so then there is a human readable description of the problem. Here you can see some. I ran this evaluate tool generating some reports. And the last one, fix, will return molecules. So this one returns the Boolean, true, false. The other string description. The third one is the molecule. The fix method, if it could be fixed, if it was okay, the original molecule, if it was changed, modified, then you will get the modified one. Another integration possibility within these tools, which we plan for the future, is to provide a kind of layer on the top of the JChem base, probably on the JChem base service, which will allow you to validate the molecules before inserting them to the database. So there could be, it depends on your workflow, who will be the registrar who can modify the molecules or accept or discard them. This part is not yet done. At the moment, in all of these tools in the new version, we will have it in the form of chemical terms, so you can calculate validate the molecules inside the existing databases. And just a final slide about what is the difference between Standardizer and structure checker. So structure checker is a validation. It could be used in a living system before inserting the molecules in the database, because you want to find the crap ones, the invalid ones. Standardizer sits inside the database, and it guarantees molecules are inserted. Those are accepted molecules, but maybe the nitro groups are ionic or neutral and other forms. So Standardizer, we consider Standardizer, though it contains a canonicalization tool and structure check tool. And this is the team who worked with me on this tool: Attila Szabó, István Ráben, and Zsolt Mohácsi. And if you have any questions, I would be happy to answer. Thank you. Yes, Richard is coming.
I'm just curious if you've run this over anything like the NCI database and what the error rate was, if you happen to do that.
Yeah, I ran it on two larger data sets. One was from a big publisher who was very interested in their own errors. There were plenty. The ratio of these kind of errors is interesting. For example, bond angles is a very typical one, so most of them are these cleaning-related ones. But also wedge problems were very common. I ran it on PubChem as well, and I was surprised at how many invalid structures are registered in PubChem, because everyone can see it, it's a human curated set of molecules, but still there are plenty of errors, and those errors are there. Actually, currently some problems can be very tricky to realize. So we follow a kind of policy that we do not warn you if we are unsure. So we try to make the tool that it will warn you only if we are sure that there is an error, not to disturb the users with many fake error reports. So if you try this tool and you see some false reports, just tell us, because it was unintentional. But it can happen that some kind of special bond angles go through. For example, we have this envelope type representation of cyclopentane or 5-membered rings. We detect that one, and we won't warn you that invalid bond angle or invalid bond length. But there might be other accepted representations that we do not check correctly.